Okay, let's solve this problem together. So in this case, you could see, you need to see that self is actually Z. And you need to have a look at this figure. And Z is going to be a left child of Y. Okay? And new root is going to be the right child of Z, which is Y here. So the new root is going to be self right. It's going to be new root. And self Z is going to have the left child of Y as its right child. Okay? So root F left, which is T1, is going to be the right child of self here. Okay? And after we did this, because the height might have changed, so we need to recompute height like this. And the left part of root is going to be self. And because the height has changed, we are going to recompute height for root. And we're going to return root. And after we implement rotate left, rotate right is quite similar. We just need to put the self left as a new root. And here, we need to exchange right to left, left to right. And we're going to recompute height for self. And root right is going to be self. And we need to recompute height for root. And we're going to return root. Okay? So this is rotate left and rotate right. I'm going to move these methods down here. And because we have implemented rotate left and rotate right, now we can implement restructure. So we need to check if self right height is larger than self left height. And this is going to be the case 1. The right height is larger than the left height. So this is going to be case 1, like this. And in this case, what we needed to do was rotate left. This was what we needed to do. Else, this means the left height is larger than right height. In this case, we needed to do rotate right. So you could say this is case 2. And as we saw in the class slides, to handle cases 3 and 4, what we needed to do was performing double rotations. And before we rotate left, what we needed to do was rotating X once more. So how can you deal with that? Before we perform rotate left here, you could check one more condition. If self right dot left height is larger than self right dot right height, And this is going to be case 3. And what we are going to do is we're going to rotate right once again. Then it will become the middle picture. And then we can perform the general rotate left, and it is going to become the third figure. So in this one restructure method, we can handle the 4 cases. So here, we could add one more condition, checking. In this case, if right height is larger than self left height, then we're going to perform rotate left, and then we could perform rotate right. So in this way, we can handle the 4 cases. This is going to be case 4 specific condition. Okay. Now we have implemented rotate left, rotate right, and restructure. And I told you that when we do insert operation, then the unbalanced situation occurs. So we need to modify this insert method in some way. And this is going to be our next PPP exercise. You just need to modify just some part of this method. And you just need to utilize this restructure method to handle the imbalance. I'll give you some time and try to modify this insert method so that we could utilize this restructure method we've just implemented.